of the semester. All right, we're going to do 10.3b. And we're going to continue our discussion on numerical statistics. Numerical stats. And yesterday when we put all that data in and we did one variable statistics, a bunch of stuff came up that we didn't talk about. We scrolled down. We're going to talk about that stuff that comes up, okay? That first stuff. All right, so here we go. We have, first part is all about the mean. Okay, so your 3 M's, mean, median, and mode. We did median already. We did that yesterday. And now we're going to do mean today. And mean describes the center of distribution. The mean is just the average. So you guys always ask me, what was the average on that test? Because you want to compare yourselves to others, right? Like if you got a 77 in my class, is that bad or is that good? So sometimes when you're in college and you get a 77%, that's good. It's really good. And then the class average is a 43. I'm not kidding you. It's crazy. And then they have to skew everything. They move all the stuff over. Okay. So other names are arithmetic mean, arithmetic average, stuff like that. It's just the average. What we do is we label it. It looks like this, X bar. Remember Z bar? Nothing? Okay. Here we go. Equals. And what you do, X bar is X1 plus X2 plus X3 plus all the way to X sub n. And what you do is you take all those numbers and you're going to divide it by however many numbers you have, n numbers in this case. Okay? When you take upper division statistics, they write it like this, 1 over n sigma I equals 1 to n for x sub I. And it's very confusing. You're like, what is that? It just means to add up all the numbers and then divide by how many there are. It's the average. Okay? All right, so for example, we're going to go back to baseball. Okay, so Roger Maris, number one. Good old Roger Maris. You guys are learning so much about baseball in here. It's so fun. He had a bunch of home runs, right? And we listed them, and then Tristan taught us how to sort those in order. That was really cool. But we can find the average. We found his median. The median was 19.5. Do you remember that? I remember that for some reason. So let's go ahead. Let's go ahead and put this in to our calculator. So 14, 28, 16, 39, 61, 33, 23, 26, 8, 13, 9, and 5. So those are the amounts of home runs that he hit in each of his seasons that he played baseball. So his first year, he hit 14 home runs, and in his last year, he hit 5. And remember that 61, that was an outlier. That was a big one. I was like, whoa, that's too many that year. Okay, so let's go ahead and input this in. So go to Stat, Edit. You might have stuff in here. You can just clear them out. Just clear L1, clear L2. We're starting fresh today. 14, 28. Okay, so go ahead. Do you want me to move that? Sorry. You probably want to see the numbers, don't you? Okay, I'll type them in. You type them in. And we've learned to do a lot of things with this data. We learned to make a histogram, a frequency table chart. We've learned to make a box and whisker from this. We learned how to find the outliers. Oh, Yochon, you didn't learn any of that. You weren't here. Are you good? Are you in AP Stats? Oh, you could teach this. Here, come up here. Teach this. Okay. We learned a lot of that stuff. So go ahead and input all that. And what we're going to do is we're going to go to Stat and go over to Calculate. One variable statistics. And there we go. So that first number right there is the average. It's the mean. Okay, X bar. X bar is 22.9 approximately home runs. That was his average. Okay, do you see the summation of X? That's adding them all up. all of these added up is 275. The summation of x squared, you don't need to know that. You will. Do you do that in AP Stats? You need to know that, huh? Yeah, you need to know all of these. We're going to learn what this SX and what that guy is. What is that guy? Do you know? What that is in Greek? This one. Did you know that one? No? I forgot too. Oh, it's lowercase sigma. It is. It's sigma, but it's lowercase sigma. Yeah. Oh, drugs are ready. Okay. Someone's phone's ringing. Answer it. Your drugs are ready. It's exciting. It's Friday, so. Okay. All right. Hi, Mom. I'm in class. Shut up. Okay. Here we go. Let me erase that. Okay, so we get 22.9 home runs. Okay, so let me go ahead and talk about the mean and the median and which one do we want and why which one's better or not better, okay? So the mean can be affected by outliers, okay? So that 61 is getting averaged into the mix with all of it. And so what happens is that's why his mean was 22.9, which was bigger than his median. The median, what this does, it's kind of a better judgment when outliers occur, okay? It's the middle. So that 61 could have been 50, or it could have been whatever. And you look at the middle number, and that's actually a better judgment of how many home runs he hit. The 61 skewing things for the average. Yeah?
Do you take out the outliers of the high school of this period for their tests? That's better.
Take the outliers out?
Yeah.
Oh, no, because a large group of them get like 102%. They're not outliers.
Oh, okay.
The outliers are the kid that gets like an 80% in that class. That kid's an outlier. Isn't that sad? Yeah. Okay. Oh, wait, for your class. That's for your class, not their class. Shh, don't say that. They watch the video and they get mad at me. Okay, so we need to look at the distributions. Like if they say the median family income in America is whatever, that makes a big difference. All right, so let's go to page 709. 709, okay? And we're going to do the next problem. The next problem is going to have a frequency table on it. And I didn't do this very well yesterday. Okay, so let's look at number 2. Number 2. All right, it says that page 709 in your book, you might want to have your iPad and your book out. It tells you the score of a certain quiz. So kids took a quiz. And this quiz was out of 10 points, okay? And 2 people got a 10 on it. 9, 2 people got a 9 on that quiz. 8, 3 people. 7, a score of 7, 8 people. So this is the score is right here, and then this is the frequency down here. And then 6, 4. 5, 3, 4, 3, 3, 2, 2, 1, 1, 1, and someone got a 0. Oh, that's sad. I know, that's really sad. Okay, so for L1, you're going to enter in the score of the quiz, and L2, you want to do the frequency, how many times it occurred. You don't have to write 10, 10, 9, 9, 8, 8, 8. You know, that would just be a waste of time. So L1 goes in the score. So let's do this together, okay? So stat edit. Clear that out. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Someone got a 0. Okay, and then enter in their frequencies into L2. And make sure they match up at the end, and you didn't skip anything. So go ahead and get those in, okay? And you guys have fancier calculators than I do, a lot of you. Some of you don't, and that's okay. when you go to stat calc, this is what I taught on a little bit at the very end yesterday. You're going to go to stat calc and you're going to do one variable statistics and you're going to do L1 comma L2. If you have a newer calculator, it'll say frequency. You can put L2 in where it says frequency. So if it says frequency, you want to put L2, which is second 2. Okay? And then that's going to tell you. And you know what I like to do? Here, let's go ahead and do it. Stat calc, one variable statistics, and you're going to put L1 comma L2 if you have an older calculator like I do. Then hit enter. And I like to look at that N right there. N equals 30. There are 30 people in this class. Okay, I like to make sure that it actually did the frequency of it. So there are 30 people in this class, and what was the average score on that quiz? Not very good, was it? 5.9. That person might want to think about reteaching this lesson to them or something. 5.9. Maybe it was like a pre-quiz. Like, let's see what you know about the American Revolution. I'd be the 0 over here. That would be me. Who teaches that? Brass? No? Okay, and then what's the median? The median here is, you got to scroll down. The median's a little higher, which is nice. It's 6.5. 6.5. Okay, that's good, that's good. What about weighted means? Do you like when your teachers give you a weighted grade? I can't stand it. You like that? Really? I don't like it. Like they'll say that all the tests are worth 25%, so your grade isn't based on total points, and you have to figure out like your grade a certain way. There's a way to do that, and that's really tough. Okay, so we're going to do one of those next, number 3. All right, it says here, at Marty's school, it's an administrative policy that the final exam must count 25% of the semester grade. Can you imagine that? Your exam is going to be 25% of your grade. That's not in this class, it's only 15, all right? Now, if Marty has an 88.5 average going into the final exam, that's the average before the exam. Do you ever do this? Like, what do I need to get on my exam? Yeah. When you do total points, it's a lot easier, but weighted averages, it's going to be tough. What is the minimum exam score needed, what do you think, to get a what?
An A?
Yes. So what does this person need to get? What does Marty need to get on the exam to earn a 90% in the class? To earn a 90%. Okay, here we go. This is what we're going to do. This is a little bit tough. Oh, they did that. That's cool. All right, it says that the average right now is 88.5%. That's what Marty's getting. How much percent of the grade is that grade?
75.
Perfect. It is. That 88.5 is 75% of Marty's grade. Plus, how much are they going to get on this exam? X. Not sure. And how much is that a part of the grade? 25%. Okay? And this needs to equal, oh, they put it over 1, which is 100%. You don't need to worry about that because you know it's going to be out of 100. They put it equal to 89.5 because a lot of teachers round up. Do you have teachers that don't round up? Yeah? I round up, yeah. It's actually a thing in Power School that you can set, and I set it to round up. Yeah. What I also do is I look at your grade and I see if you're within 4 to 5 points. I kind of find some points for you. Shh. And we're back. So let's go ahead and let's figure this one out, okay? So we have 88.5 times 0.75, and that's equal to 66.375. We're going to subtract that from 89.5. So we have 0.25x equals 23.125. So I multiplied those together, subtracted it to the other side, divide by 0.25. Whoa. So Marty, little Marty's going to need to get a 92.5% on his final exam. Or her. Marty's a girl name too. Okay, woo, that's a good one. All right, now we're going to move on. So that's mean, that's the average. It's finding your average grade. Now we're going to talk about variance and standard deviation. Ooh, these are Yochan's words. No? Variance and standard deviation. Now I just teach you kind of the easier way. When you get to AP Stats, it's a little more complicated there than this. We're just going to do some basics, okay? All right, so standard deviation. Do you know what standard deviation does? You do? Can you explain it, or do you want me to explain it? Do you know what standard deviation does, Sam?
Like some average difference from the mean.
Yes, yes. Yeah. Look at Jeanette's impressed. What it does is it measures your spread of your data, doesn't it? Okay? It kind of measures the spread of your data. It measures where your mean is, where your average is, and how far it goes from there. Measures the spread of your data. See, in statistics, you want your data kind of close together, right? If it's all over the place, it's like, okay, is there any kind of correlation here? But when it's together, it's nicer that way. Now, the standard deviation of a population is this little guy. Do you know what that's called?
U?
Oh, close. It's mu.
Oh.
MU, mu. It's mu. This is the population mean. Yeah, statistics, they like to use Greek letters a lot, don't they? And then variance. Oh, wait. Before I say variance, sorry. Don't do variance yet. We need standard deviation before variance. Standard deviation is this guy. Sigma, lowercase sigma. I probably don't write it the same way Cowie does. I think she kind of rounds hers more like that or something, but I'm not very good at writing that sigma. And then variance is going to be standard deviation squared. Okay? It says typical 2/3 of the data values are within 1 standard deviation of the mean. That's typical. Okay, the larger standard deviation is, the larger this number is, the more spread out your data is. All right. If you have standard deviation and it's this sigma guy right here, then that's going to be over the entire population, which normally doesn't happen. Like if I go out and I say, okay, I'm going to make a statistic about people who drive BMWs, and I survey 1,000 people. That would not be, I couldn't use that as my standard deviation, sigma. I can't use that because the entire population of people who drive Beamers, I can't, talk to all of them. All right, so when we don't have an entire population, then we use S instead. And this is for it's the standard deviation of a sample population. They're usually going to be very close to one another. So some people like to use one, some people like to use a different one. Okay, so let's go ahead and we're going to do the next problem so that you know what all this stuff is. So I give you a bunch of information. You're like, okay, what is this? What do I even need this for? Here we go. Number 4. Let me check my time real quick. Extended lunch, we're out at 10:50. We're doing okay. All right. It says here, and we're on page 711. 711. It says here, a researcher measured 30 newly hatched loon chicks, the little chickens. I know, and they recorded their weights in this data that's shown, okay? So what we're going to do is we are going to find the mean and the standard deviation, okay? We can make a histogram of this. We can make a box and whisker plot. We can do all this stuff, okay? So what I want you to do is we're not going to list them all because there's like 30 of them, let's just do like the first 15. Are you okay with that? We're just going to take a sample of the 30. So get your calculators ready. If you're on page 711, if you're in the book, then you can do these. I'm just going to do them really quickly. I'm going to clear out my lists. So if you want to do this with me, that would be cool. Here we go. So this is in grams, right? Yeah, the grams. All right, so 79.5, 87.5, 88.5, 89.2, 91.6, 84.5, 82.1, 82.3, 85.7, 89.8. Let's keep going. Let's go 5 more. 84, 84.8, 88.2, 88.2 again, and then 82.9. All right, so there's 15 of them. Okay, did you get them? You guys stayed up with me? Good. All right, so here we go. Based on the sample, this our sample that we're going to do. It's a little different than the book's answer because we're only doing 15 of them instead of 30. Estimate the mean and standard deviation for the weights of the newly hatched loons. So go to Stat, Calc, and we're going to do one variable statistics. We don't need a frequency list. There's no frequencies here. Go ahead and hit Enter, and there it is. Now, you have to then decide. Okay, you know the mean. The average weight is 85.92 grams. Make sure you include units here. So X bar, which is the mean, is 85.92 grams. Now the standard deviation, there's 2 standard deviations given. There's SX and then there's sigma X. Okay? We have to decide which one it is. Sam, you know which one it is, right? Yeah, it's this one. It's sample X. Is that what she calls it, sample X? Or no? Standard deviation? No, she doesn't call it that? Okay. We're not going to use this one because that's over the entire population of chicks hatched. We don't want that one. We have a sample of them. Even if I use 30, I'd still have the sample. So the sample would be, the standard deviation is 3.41 grams. Okay, that means that our data is pretty close to one another. Okay, there's not too many outliers. It's really close. If we did it for the entire, we would get 3.51 for all 30. Okay. All right, so that's it. That's what you do there. That's pretty good. All right, then the last part, part C. Almost done. Last part. Here we're going to talk about normal distributions. Are you normal? Maybe? There are outliers. You know outliers, don't you? You know some people that are outliers? Like just in general, the way they act, the way they look. I took a test and it was, what equation are you? You remember those quizzes that you used to take on Facebook? I took one. And you know what I came up with? I was the normal distribution because I'm so average. Yeah, I'm so basic. I like being basic. I don't want to stir anything up. I'm just a nice straight path. Okay, here we go. This is the normal. It's called the Gaussian curve. Carl Friedrich Gauss, there he is again, my favorite mathematician. And this is what it looks like. It looks like your basic bell-shaped curve. It's going to go like this. Okay? This is the equation y equals e to the negative x squared over 2. You don't need to know that, but I like writing it down. Okay, so here we go. This is a normal. This is like most people fit in the middle. It's kind of like if you talked about height, right? Most people are in here, and then you have like Mr. Ornay, which is over here, and then you have Mrs. Peterson, which is over here, right? And when they walk together, it's fun. Okay, so what this says is this. If I go 1 standard deviation away from the mean is in the middle. The mean's right there. If I go 1 standard deviation in either direction, then my data is going to be all of this. It's the area under this curve right here. And do you guys know how much percentage of the population is going to be in there? How much? 68. He knew that from statistics. Okay? 68% on a normal distribution, 68% of the data will lie between plus and minus 1 standard deviations away from the mean. Okay?
Is it always like that?
Yeah, and a normal distribution is always like that. Crazy, huh? Okay, now what if we go 2 standard deviations away? You're ruining this for me. No, you know these. That's great. All right. So I go 1, and I'm at 68%. If I go 2 standard deviations away from the mean, it's crazy how high this is. This would be all the data. It's the area under the curve. You actually use integrals in calculus. It's pretty amazing. And that would be, what'd you say, 95. 95% of the data in a normal curve lies plus or minus 2 standard deviations away from the mean. That's a lot, isn't it? That's most people. 95% are going to be in that standard deviation. And then finally, 3 standard deviations away.
99.7.
Wow, you know your statistics. Okay, normal curve again. This time we go 1, 2, 3, 1, 2, 3. All of this area under the curve, it just keeps going like that, okay? All of this in here to 3, sorry, you gotta stop at 3, is 99.7% of the data is going to be at plus or minus 3 standard deviations away from the mean. Interesting, isn't it? This is like the only part I like about statistics, seriously. I think this is so cool. Okay, now, knowing that, we're going to answer one last question. Last one. What number are we on, 5 or something?
Yeah.
Okay, number 5. Ooh, we have time, cool. It says, using the 68, 95, 99.7% rule, that's nice, they give you that. Using, that's what that's called, the 68, 95, 99.7 rule, okay? Based on the research data that we got from the chicks, the baby chicks, okay? Would a loon weighing 95 grams be in the top 2.5% of all newly hatched loon chicks? Okay, so let's see. Here we go. So let's say the loon chick is 95 grams. Okay? So would this be in the top 2.5% of loon chicks? Well, first of all, let's go ahead and let's get our information from that number 10. You need to know the average, the mean, and for all 30 chicks, they did it. We only did 15, but for all 30 chicks, the average was 87.49 grams. That's the average weight of all the loon chicks, okay? And then the standard deviation, they used S. We're not going to use sigma. We always use S. S is equal to 3.51. Okay? All right. So what you want to do is this. Yes? Do you see it?
Yeah.
What I like to do is I like to look at a graph. I go like this. And the average is 87.49. See, people think that if you draw that, that's just it's 0 right there, but it's the average that goes through the middle. What would 1 standard deviation away be? It would be 87.49 plus 3.51, which is 91. Okay, so this would be 91 right here. That would be in the 68% in there, and then I have to go one more. So add 3.51, and that is 94.51. Okay? Some people like to do it this way. You take the mean, 87.49, And you're going to add 2 standard deviations. Or, you know what, let's write the mean instead. To find out if you are in the 95th or in the top, okay, so 95, I should have explained that a little bit better too. Ew. 95% is 2 standard deviations away, but that means that this right here is 2.5%. Okay? Because what it's out of 100%, right? So I'm missing 5%, but I have 2 sides of this. So 2.5% are over here, and 2.5% are over there. Does that make sense to you? Yeah. Okay. So for this one, you're going to take the mean and add 2 times standard deviation. And what happens is you get 94.51. So any chick that's more than, any chick that is greater than 94.51 grams will be in the top 2.5%. Because that's where it got us to with our 2 standard deviations. So would a chick weighing 95 grams be in the top 2.5%? Yes. The answer is yes. You have to test it that way.